Hey guys, we're going to move on to chapter 4 today, which talks about ecosystems and communities. And I really feel this chapter is a lot of stuff you're somewhat familiar with, so we'll kind of just talk about some things and some minor details, just get a little bit more into it than maybe you have in the past. Make sure you're using the Cornell note-taking method. And again, you're more than welcome to download the templates off my website on Schoology, or you can just do the technique on a separate sheet of paper. Okay, so the first section, 4.1, is over climate. And when you think about climate, you might be thinking about like hurricanes and floods, kind of like Hurricane Katrina that destroyed New Orleans that one year, the drought that parches the southeast. But big storms and seasonal droughts, hurricanes, tsunamis, things like that are better described as weather rather than climate. Climate and how it's different from the weather and how they affect organisms and the ecosystems is what we're going to talk about in this section. So weather is your day-to-day condition of the Earth's atmosphere. It's what you hear on TV if you listen to the news and what they report, or the meteorologists report for the weather that day. Now, climate refers to the average conditions over long periods of time, and it's defined by year after year patterns of temperature and precipitation. So it's an overall how is the temperature in that area and what are the patterns that we're seeing. Climate, it's rarely uniform even within a region. Environmental conditions can vary even over small distances, and we call those small areas that kind of have those different things going on microclimates. It's kind of like, in Missouri, we always say wait a day and you'll like the weather better because it's always, jumping back and forth. And, in St. Charles, it could be hailing, and in Florissant, which is in North County, it might be doing nothing at all. So you might consider those kind of small little microclimates in a way. Alright, so there are certain factors that will determine our global climate and what conditions take place in different areas around the world. Solar energy trapped in the biosphere, latitude, transport of heat by winds and ocean currents, and then the amount of precipitation that takes place in a given area. Now I want to talk a little bit more about latitude. The difference in heat distribution that creates 3 different climate zones. They're known as tropical, temperate, and polar. So in your polar zones, you're going to have less direct sunlight and therefore cooler temperatures. Move in a little bit, you get a little bit more direct sunlight in those temperate zones. But then once you hit tropical, which is most of those areas along the equator and really close to the equator, you have your tropical zone, which is getting the most direct sunlight, therefore having the higher average temperatures throughout the year. Again, we live more in a temperate zone where we have all 4 seasons, some a little longer than others, like the winter we've had this year. Again, that depends on a lot of other environmental factors that we just mentioned. Okay, but solar energy is the most influential force. Some is reflected back into space. Some is absorbed and converted into heat. Some of that heat can radiate back into space, but some of it is trapped in the biosphere. And we're going to talk about that a little more in a second here. That balance between heat that stays in the biosphere and the heat lost to space really determines Earth's average temperature. Now, greenhouse gases. This is what I was talking about. We're going to get into how Earth traps heat. If greenhouse gas concentrations rise, and we're talking about mainly carbon dioxide, they trap more heat. So the Earth warms. If their concentrations fall, more heat's going to escape and Earth is going to cool. Without the greenhouse effect, the Earth would actually be about 30 degrees Celsius cooler than it is today. Now, Earth's temperature is largely controlled by a concentration of 3 atmospheric gases. I told you carbon dioxide is the main one. Another one is methane, and then there's also water vapor. We consider all these greenhouse gases, and they function kind of like glass in a greenhouse, allowing visible light to enter, but trapping heat through a phenomenon called the greenhouse effect. And that's why you have those greenhouses that house plants usually over certain times of the year, because they're trapping in that heat needed for those plants to do well. Now, 4.2, we're talking about niches and community interactions. We've talked about niches a little bit before. We'll get into some more detail here in a second. But if you ask someone where an organism lives, that person might answer on a coral reef, or maybe in the desert, or maybe in a forest or a jungle. And these answers give the environment or location, but ecologists, when they're studying these organisms, they need more information. They need to understand fully why an organism lives there, where it does, and how it fits into its surroundings. So what they also need to know is that organisms niche in that environment. And a niche is the range of physical and biological conditions in which a species lives and the way the species obtains what it needs to survive and reproduce. Remember, that's just the definition of fitness. So all species want to have a high level of fitness. Every species also has its own range of tolerance. Okay, the ability to survive and reproduce under a range of environmental circumstances. So if the temperature gets high, that puts some organisms under stress. Like for us, if the temperature is over 100 degrees and the humidity is really high, we generally don't go outside because that puts us under stress. It puts us in danger for having heat strokes, heat exhaustion, things like that. So it's the same for any other organism. They all have certain tolerances that they need to learn how to control, otherwise they may not survive. So again, a species' tolerance for environmental conditions then helps determine its habitat or the general place where that organism lives. An organism's niche does not only describe the environment, but also how it interacts with the biotic or living factors, the abiotic, non-living factors in that environment. So I have some examples here for you. Resources, that can refer to any necessity of life, such as water, nutrients, light, food, or space. So for plants, we're probably thinking resources include sunlight, water, soil, nutrients. That's basically the gist of it. It'd be nice for some plants, especially flowering plants. They like to have organisms like bees around to help transport their pollen so they reproduce better. For animals, basic resources can include nesting space, shelter, types of food, and places to feed. All right, another example is organisms interacting with other organisms in the following ways. Organisms can compete with each other, known as competition. So that occurs when they attempt to use the same limited ecological resources in that same place at the same time. Predation is an interaction in which one animal captures and feeds on another animal. So the one that is the animal capturing is the predator, and the one that they are feeding on is the prey. Herbivory, an interaction in which one animal, which is the herbivore, feeds on producers, we know are plants. And then there's also these three symbiotic relationships that you need to become familiar with. They are parasitism, mutualism, and commensalism. And any relationship when two species live closely together is known as symbiosis. And this just means living together. Alright, now we're going to move on to the next section, and I want to share a little story with you that's in your textbook. In 1883, the volcanic island of Krakatoa in the Indian Ocean was blown to pieces by an eruption. The tiny island remained completely barren. After 2 years, grasses were growing, and after 14 years, there were 49 plant species, along with lizards, birds, bats, and insects. So in the background, you can actually see the island of Krakatoa, and that is a volcano that had erupted. By 1929, a forest containing 300 plant species had grown, and today the island is blanketed by mature rainforest. The events that occurred after the eruption on Krakatoa is an example of ecological succession. And that's what section 4.3 talks about, the different types of succession, which there are two. Now, the definition of succession is just a series of more or less predictable changes that occur in a community over time. Ecosystems naturally change over time. This especially occurs after a disturbance such as the volcanic eruption, and it results in species dying out, allowing new species to move in. And generally during a succession, the number of different species present will increase to what it had been before. Okay, so two types of succession. We have primary, and this is when succession begins in an area where there are no remnants of an older community, kind of like the volcanic eruption of Krakatoa. Secondary succession is when succession occurs following a disturbance that doesn't completely wipe out the community. Now, the first species to colonize barren areas, so this is primarily talking about a primary succession, would be a pioneer species. And they're named that because, like, kind of like the human pioneers who first settled into the wilderness and started communities in that respect. Now, it's also important to note that not all ecosystems follow their original path following a succession. So what I mean is there may not be the same organisms that reincorporate themselves into that environment. Now, if we're talking about secondary succession, though, in a healthy ecosystem following a natural disturbance, often they reproduce to the original climax community. Now, what is a climax community? It is a final stage of biotic, and biotic just means living, okay? Succession attainable by a community in an area that is under the environmental conditions that are present at that particular time. Okay, that wraps up Chapter 4 for us. Chapter 4.4 talks about biomes and the different types that we have globally, and we'll get into that more in class. So I will see you later, and make sure you go back and pause and take a closer look at anything that you felt like you missed or didn't have enough time to get down good notes at. And again, please practice that Cornell note-taking method. Have a good day.